The Great Rift Valley is a geological wonder, visible even from space. A breathtaking 6,500-kilometer depression in Africa, with the East African Rift at its heart. This area of remarkable beauty also conceals a powerful secret. It is one of Earth's most tectonically active fault lines. Beneath the feet of 120 million people, a colossal force has been pulling at the continent's foundation for over 20 million years. Marine geophysicist Ken McDonald suggests this area could become a new, smaller continent. The traditional shape of Africa would be unrecognizable, replaced by a large island and a new continent in the Indian Ocean, comprising parts of Ethiopia, Somalia, Kenya, and Tanzania. This transformation could affect biodiversity, water resources, agricultural practices, and the continent's geopolitical landscape as new maritime routes emerge and nations reassess their borders. Currently, GPS measurements indicate the Nubian and Somali plates are separating at an average rate of 7 mm per year, although estimates vary. At this rate, it would take tens of millions of years for the Somali plate to completely break away and form a new ocean. However, there could be potential upsides. The upwelling of magma provides access to a rich source of geothermal energy. This could enable countries along the rift to become energy self-sufficient. Ethiopia and Kenya already have a combined geothermal power generation capacity of over 1,100 MWh, with the potential for significant increases. In a world seeking renewable energy, the East African Rift System could be an economic goldmine. Despite ongoing debate, compelling evidence supports the possibility of a split. In September 2005, a large crack appeared in Ethiopia's Afar region, seemingly overnight. This crack was triggered by the eruption of the Dabahu volcano, which had been inactive in recorded history. The volcano swelled, followed by a swarm of 131 earthquakes, and then an eruption that blew out a vent of boulders and ash, leaving a large crater. Researchers found that a 60-kilometer-long, 8-men-wide dike of solidified magma formed in the rift, causing the crack in a matter of days. In 2018, a 1-kilometer chasm opened up in Kenya. While the larger rifting system may have been a factor, the sudden appearance was likely due to heavy rainfall. The pre-existing crevice, filled with volcanic ash from past eruptions, was exposed when the deep layers of ash collapsed and were washed away. However, the possibility of a failed rift presents a more concerning scenario. Geological forces driving the rifting might prove too slow to separate the Somalian and Nubian plates. As Cynthia Ebinger notes, failed rifts mark continental landmasses worldwide. The Mid-Continent Rift in North America, a 3,000-kilometer feature that once threatened to split the continent, stalled and solidified over time. This rift is now marked by vast deposits of basalt, acting like a geological glue that has held it together for 1 billion years. Continental rifting occurs when magma below the surface is forced upwards, ripping open the lithosphere. In the Mid-Continent Rift system, the crack through the Earth's crust failed to fully open. The magma, under enormous pressure, burst through cracks and flowed onto the surface. Over 2 billion cubic kilometers of lava erupted, with individual flows exceeding 600 cubic kilometers. If the East African Rift System cannot spread sideways, the enormous pressure will have nowhere else to go but up. Are the cracks early warning signs of a potential failed rift, leading to a global disaster? While similarities exist between the Mid-Continent Rift and the East African Rift System, there are also differences. Predictions remain speculative. We rely on the analysis of lava flows and seismology to understand what's happening beneath the surface. Geological models indicate a super plume of hot magma rising underneath the East African Rift System, similar to conditions at the early stages of the mid-continent rift system. If the East African rift system behaves like the mid-continent rift, we can expect effusive eruptions, which are less violent but involve much more lava. Lava flows, similar to those in North America, could cover nearly half of Ethiopia, most of Kenya, and even extend into Uganda and Tanzania. The East African rift system is 3 times bigger than the mid-continent rift. There have been no effusive eruptions in human history comparable to this scale. The 1783 eruption in Laki, Iceland, which released 14 cubic kilometers of lava, caused widespread haze, crop failures, and famine. A giant crack is slowly but surely ripping through Ethiopia, Kenya, and Tanzania, threatening to divide Africa in two. This video will explore the forces of nature behind this geological powerhouse, addressing whether the second largest continent is truly tearing itself apart and the potential consequences. What impact could this continental reshaping event, the biggest since the breakup of Pangaea, have? In comparison, a single lava flow from the mid-continent rift exceeded 600 cubic kilometers. The consequences of similar effusive eruptions in the East African rift system would be severe. The East African rift system is the largest seismically active rift system globally, with 78 active volcanoes. Monitoring of dormant volcanoes between 2003 and 2008 showed signs of deformation, indicating impending disaster. Growing volcanic activity and more frequent, higher-intensity earthquakes raised concerns about the East African rift system's movements. In 1977, Mount Nyiragongo erupted, emptying a lake of unusually liquid lava at speeds of 60 km/h. It erupted again in 2002 and 2021. Old Donyo has been more active since 1983, erupting in spectacular fashion in 2007 and 2008. Satellite monitoring indicates increased activity in the magma below. Volcano movement and bulging indicate increasing pressure of the underlying magma. Old Donyo produces natrocarbonatite lava, a unique type of lava with an unusual composition and low eruption temperatures. This lava remains liquid at much cooler temperatures, allowing it to flow faster and further. If this coincides with a global downturn in food production due to a volcanic winter, there will be starvation on an unprecedented scale. These changes are likely to be slow, occurring on geological timescales rather than human ones. As the earthquakes and volcanic eruptions continue, scientists will monitor the movements of the land surrounding the rift, hoping to detect signs of what is happening beneath the surface. The pressure is building, and something has to give. Whatever happens, the reshaping of this majestic continent is underway, and will redefine the face of planet Earth. The shape of the African continent will look very different one day. However, Kevin Burke and John F. Dewey presented compelling evidence that the African plate had been separating since the Cretaceous period. This separation creates the East African Rift System, a divergent plate boundary where the Somalian and Nubian plates move away from each other. Adding to the complexity, these plates are also separating from the Arabian plate to the north, forming a Y-shaped rifting system known as a triple junction in the Afar region of Ethiopia, fueling concerns about a potential split. The Earth's lithosphere, the solid rock layer comprising the land and ocean floors, is central to these tectonic plate movements. This relatively thin layer, often compared to the skin of an apple, floats on the mantle, a layer of semi-solid rock behaving like a slow-flowing liquid. Heated by the Earth's core, as hot as the sun's surface, this semi-solid rock rises, flows outwards beneath the lithosphere, cools, and sinks again. These thermal currents drive continental drift, a key factor in the breakup of the ancient supercontinent Gondwana about 180 million years ago, resulting in the landmasses of Africa, South America, Australia, Antarctica, the Indian subcontinent, and the Arabian Peninsula. The leading theory for Africa's potential split centers around a superheated plume beneath the lithosphere. This plume, driven by the Earth's core, rises, lifts, and eventually cracks the supercontinent. This process dragged Africa and South America apart, relieving pressure and allowing gravity to form the Atlantic Ocean. A similar process more recently formed the Red Sea at the northern end of the East African Rift System, a geologically unstable valley surrounded by mountains pushed upwards, eventually reached breaking point. The valley thinned and weakened as the Arabian Plate separated from the Nubian Plate, leading to the collapse of the stretched lithosphere and the gradual opening of the Gulf of Aden and the Red Sea. Discussions continue about whether the same process is occurring in Africa, with the prevailing hypothesis suggesting that rising thermal plumes in the Earth's mantle are causing an upward bulge and stretching of the lithosphere beneath Kenya and Ethiopia. This lithospheric thinning has resulted in extensive basalt lava flows erupting from newly formed fissures, fracturing the brittle continental crust into a system of faults. Given this history of continental splitting, the concern is understandable. If Africa does split, the land within the widening Rift Valley will eventually sink, allowing water from the Indian Ocean to flood the basin and create a sixth ocean.